Okay, hopefully you guys are all doing really well. Today we're going to look at the next section, which is parts of similar triangles. In the last section we talked about similar triangles. Hopefully you guys got an idea of what we're looking at. This one we're just going to extend it and pick out a few different things that are important to know. Okay, so we're going to look at a few theorems. The first theorem says, if two triangles are similar, the lengths of their corresponding altitudes are proportional to the lengths of their corresponding sides. Now remember, altitude is the line that comes from a vertex and meets at a right angle. Okay, so it must drop from a vertex and meet at a right angle. Those two things are going to be proportional to the side lengths. So what you can see here is I've got an altitude of 4 over a side length of 6. That means in the other one I've got an altitude of 2 over a side length of 3. If those two things are proportional, then they will be similar, and that's what that shows. Okay? The second theorem says if two triangles are similar, the length of their corresponding angle bisectors are proportional to the lengths of their corresponding sides. Same basic idea, but an angle bisector, if you guys remember, is the line that cuts an angle into two congruent parts. It bisects it. So what that shows is if I have a side length of 4 and an angle bisector of 6, I can set that up as 4 over 6. Here I have a side length of 2, an angle bisector of 3. I can set that up as 2 over 3 since those are corresponding. That reduces down. It is equal. Those two figures are similar. Okay, so we've got the altitudes, we've got the angle bisectors, and finally we have the medians. Now remember, the medians meet at the midpoint of the opposite side. Okay, it does not have to be a right angle though. All that shows is that these two smaller sides in each of these triangles are congruent. Now this sets up the same way. I've got a value there of 4. I've got a value here of 6. So that's 4 over 6. The median over here is 2 over the side length of 3. So it's 2 over 3. Those are congruent. And so those figures are similar. So you've got the altitude, the angle bisector, and the median. As long as those are proportional to the side lengths, the figure is similar. Alright, so here is the examples we're going to go through. It says in the figure, ABC is congruent to FDG. Find X for each set of triangles. Okay, so they're just giving you a couple different things that we've talked about. They want you to figure out what X is. Now in this first one, if you look at the figure, you've got an angle bisector. Okay, so we've got angles here that are congruent, angles here that are congruent. That is proof that it's an angle bisector. So we take our angle bisector length, which is X and 8, and you can set them up in this form, or you could set them up in the form I showed above. Since the X is in the numerator here, the 15 has to be in the numerator as well. The 8 is in your denominator. That means the 12 has to be in your denominator there. Okay, so that's the way this sets up, and it all just creates a proportion. So we cross multiply, you get 8 times 15. 8 times 15 is 120. 12 times x is 12x. Divide by 12, and you get an x value of 10, and problem is solved. Now in the second one, you look at the figures, and this one we've got medians. Okay, so we got medians. So we set this up the same way. You've got a value here of x, you've got a value here of 13.5, and in this case you could set it up like x over 13.5. That works. Now if you look at this, this is not a corresponding part, except for the fact that because these two are congruent, that one is also going to be 3. So now you've got corresponding parts and it works out. So I've got this part over my median, which is 3 over 9, and from here I can solve. So we cross multiply, you get 9 times x, which is 9x. You got 13.5 times 3, which is 40.5. And then you divide by 9, and 40.5 divided by 9 is 4.5, and there's the value of your x. Okay, so it's all, again, just setting up these ratios, understanding what they're asking for. Alright, final one, using what we've already seen. Pause the video, see if you can figure this one out. Okay, so you guys should have had time to work this one out. Let's see what happens. So in this first figure, we've got an altitude of 16, a side length of 20, so I can set that up as 16 over 20. In the second one, I've got an altitude of x, a side length of 15, so I set it up as x over 15. And then I cross multiply. So 15 times 16 is 240. 20 times x is 20x. And then solve for x. So divide by 20. And that gives you an x value of 12. And there's your solution. Now, one of the things you really want to watch for is making sure that you pick out the corresponding parts and set them up in the correct order. Okay, so if I have an altitude over a side for my first one, I need to make sure I have an altitude over the side in the second one. Okay, if I put my altitudes of the first figure over the altitude of the second figure, I want to put the side of the first figure over the side of the second figure for my second ratio. Just watch that. That's one of those pretty common errors that I've seen over the years, and I would just hate to see you guys make that same mistake. Alright, good luck. If you need my help, please contact me online. Otherwise, I will see you in the next lesson.